carbon and its compound. Versatile nature of carbon. Versatile nature of carbon.
Bonding of ethanol.
Occurrence of carbon. Allotropes of carbon. Diamond, graphite, Buckminster Fullerene. Versatile nature of carbon. The nature of the covalent bond enables carbon to form large number of compounds. These compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in rings. Example: normal butane, isobutane, and C60. In addition to it, carbon atoms may be linked by single, double, or triple bonds as well.
Bonding of ethanol or ethyl alcohol.
The two carbon atoms will share each their one electron to form one carbon-carbon covalent bond. The 6 hydrogen atoms will share each their one electron with carbon to form 6 carbon-hydrogen covalent bonds and make an ethane molecule, C2H6. Two factors noticed in the case of carbon are: 1. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. 2. Compounds of carbon which are linked by one single bond between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. Since carbon has a valency of 4, it is capable of bonding with 4 other carbon atoms or atoms of some other monovalent element. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with specific properties which depends on the elements other than carbon present in the molecule. Occurrence of carbon. Carbon occurs in nature in free state as well as in combined state. In free state, carbon occurs in nature mainly in 2 forms, diamonds and graphite. Recently, in 1985, Buckminster Fullerene or C60, a form of carbon, has been discovered naturally occurred in free state. In the combined state or say compound form, carbon occurs in nature in the form of carbon dioxide gas in air. Carbonates like limestone, fossil fuels like coal, petroleum, and organic compounds like carbohydrates, fats, and proteins. Allotropes of carbon. The various physical forms in which an element exists is called allotropes of the element. Diamond, graphite, and Buckminster Fullerene are 3 allotropes of carbon. Diamond. Diamond is a colorless, transparent carbon form having extraordinary brilliance or shine. It is the hardest natural substance known as quite heavy. It is a bad conductor of electricity. If diamond burns on strong heating in the presence of oxygen, only carbon dioxide gas is formed and nothing is left behind. The carbon dioxide formed by burning diamond can turn lime water milky. Diamond is made up of carbon atoms only. Its symbol is taken to be C. Structure of diamond. A diamond is a giant molecule of carbon atoms. The carbon atoms are powerfully bonded to one another by network of covalent bonds. This rigid structure of diamond makes it a very hard substance. Each carbon atom is linked to 4 other carbon atoms by this strong covalent bond. This arrangement of carbon atoms is tetrahedron and gives high density to the diamond crystal. A lot of heat energy is required to break the covalent bonds. The melting point of diamond crystal is also very high,
more than 350 degrees Celsius.
Since each carbon atom is linked with 4 other carbon atoms, all 4 valence electrons of each carbon atom is used in forming the bonds. Therefore, there are no free electrons in a diamond crystal. It does not conduct electricity. Uses of diamond. Diamonds are used in cutting instruments like glass cutters and in rock drilling equipments. Diamond dyes are used for drawing thin wires like tungsten filament of an electric bulb. Diamonds are used for making jewelries because of their extraordinary brilliance. Sharp-edged diamonds are used by eye surgeons as a tool to remove cataract from the eye with great precision. Structure of a graphite. Graphite is a grayish-black opaque substance, soft and slippery to touch. It is lighter than diamond. It is a good conductor of electricity. If graphite burns on strong heating in the presence of oxygen, only carbon dioxide gas is formed and nothing is left behind. The carbon dioxide formed by burning can turn lime water milky. Graphite is made up of carbon atom only. Its symbol is taken to be C. Structure of graphite. A graphite crystal consists of layers of carbon atoms or sheets of carbon atoms. Due to this sheet-like structure, graphite is a comparatively soft substance. Each carbon atom in a graphite layer is joined to 3 other carbon atoms' strong covalent bonds to form flat hexagonal rings. The various layers of carbon atoms in graphite are quite far apart so that no covalent bond can exist between them. These layers of carbon atoms are held together by weak forces caused to slide over one another. The carbon atoms have 4 valence electrons in it. In a graphite crystal, each carbon atom is joined to only 3 other carbon atoms by covalent bonds. Thus, only 3 valence electrons of each carbon atom in graphite are used in the bond formation. The 4th valence electron of each carbon atom is free to move. Due to this presence of free electrons, graphite conducts electricity. Use of graphite. Soft powdered graphite is used as a lubricant for the fast-moving parts of machinery and the machineries which operate at very high temperature. Graphite is used for making carbon electrodes or graphite electrodes in dry cells and electric arcs due to its electric conductivity. Graphite is used for making the cores of pencils and black paints. Buckminster fullerene. It is a very small molecule made up of only 60 carbon atoms joined together to form spherical molecule. Since there are 60 carbon atoms, its molecular formula is C60. Buckminster fullerene is a mustard-colored and looks brown and black. As its thickness increases, it is dark solid at room temperature. It is neither very hard nor soft. If Buckminster fullerene burns on strong heating in the presence of oxygen, only carbon dioxide gas is formed and nothing is left behind. Structure of Buckminster fullerene. The structure of C60 resembles a soccer ball of the type made up of 20 hexagons and 12 pentagons, with a carbon atom at the vertices of each polygon and a bond along each polygon edge. Only restriction is that no 2 pentagons touch each other. It has 60 vertices, 32 faces, and a large number of symmetries. Summary. The nature of the covalent bond enables carbon to form large number of compounds. Carbon has a unique ability to form bonds with the other atoms of carbon, giving rise to large molecules. This property is called catenation. Compounds of carbon, which are linked by only single bonds between the carbon atoms, are called saturated compounds. That is all about this subtopic, students. We will see organic compounds in our next subtopic. Keep learning!